We are live, party people. We are live. We are live, party people. We are live. What's up, party people? It's Mr. Harris, and in this lesson, we're talking about Unit 6, Lesson 7. This one, we're talking about exponents and fractions. So remember, this whole Unit 6 is about exponential growth and decay. And so in this lesson, we're going to talk about how fractions do the same thing that whole numbers do in regards to exponential, the connection to exponents, right? Because you'll see in the next couple of lessons that when it is a fraction multiplying by itself over and over again, there's a difference in what happens to those numbers. I don't want to spoil it for you, but let's just say, let's present this. Present arms. All right, so exponents and fractions. This is lesson 7 from unit 6. In this one, I want you to learn how to create equivalent expressions. I want you to also be able to determine a pattern in order to complete a table, and you can manipulate expressions involving fractions. All right, let's go ahead and look at the bridge. Remember the bridge for those of you that aren't my students. First of all, wait, hold up. Like, share, and subscribe. All right. If you're watching this live, I appreciate you. If you're watching the replay, I appreciate you. If you're watching this period, type something in the chat. I don't care if you watch it for just the first 2 minutes. I would hope that you watch it longer than that, because I need my viewing hours up. But do me a favor, if you are watching this video, type something in the chat. You can type a 1 in the chat to let me know you learned something. You could type your city in the chat, wherever you're from. My students, you could type something in the chat. Just keep it respectful, y'all. Y'all know y'all, my little knucklehead nephews and nieces. And but anyway, y'all don't want to hear me talk. Y'all want to hear me do the math, homie. All right, so it says write each expression using an exponent. Okay. So I have this first number of 1, but then I multiply 7, 7, 7, 7, 7. There's 5 sevens, so I'm just going to say times 7 to the 5th power. Same thing in number 2. I start with 1, and then I'm multiplying by 4/5. But as you can see, there are 1, 2, 3, 4, 5 4/5. So I'm going to take that 1 times 4/5 to the 5th power. You might say, well, Mr. Harris, why'd you put it in parentheses? Because it's a fraction. And to make sure that someone knows that you're multiplying 4/5 by itself 5 times, or to match with this, actually. That's why we do that. Same thing here, 1 times. Now, in this case, this is 9.3. I wrote this down when I was doing it like it was 9 times 3. So 1 times 9.3 to the 1, 2, 3, 4, 5, 6, 7, 8th power. All right. And it says the number of coins Jada will have on the 8th day if she starts with 1 coin. So that's her initial value. And the number of coins doubles every day. And on the 8th day, we have 1 times 2 to the 8th power. All right. Let's clear this out and go to the next slide. Bridge 2, this one gets a little tricky, but we can do it. So if you can see, it says Jada and Noah are comparing the average number of social media views for recent videos they've shared. Jada's views, Y, are represented in table A based on X videos shared, and Noah's views, Y, are represented in table B based on X videos shared, okay? So you can see Jada's Y values. They increase by 8 the first time, so plus 8. And then they increase by 8 the second time. So we're probably going to increase by 8 again. And that's going to give me 34. All right. And then notice it says 25 for our value of X. So we started out with, in this case, we started out with, if we go back here and we subtract 8, so 10 minus 8, let's do it like this. Let's write it like this. So if we go do the pattern in the opposite direction, so 10 minus 8 gives me 2. So if I had a 0 here, my value would be 2. Okay, so I start out with 2 plus, and we're increasing by 8 every time. And so 2 plus 8x. X in this case is 25. So 2 plus 8 times 25 8 times 25 is 200, and then plus 2 is 202. All right. So notice we can work forward and we can work backwards to find out what our initial value is if they don't give us an initial value. So here, they don't give us an initial value. Let's figure out what that is. Well, we got to work backwards. We got to figure out what are we doing first, okay? So if I go from 10 to 40, that's times 4. And if I go 40 to 160, that's times 4. So we know we're multiplying something by 4, okay? But we don't know what this initial value is. So if I do 10, the opposite of multiplying by 4 is dividing by 4. So to find that 0 value, it's 10 divided by 4 should equal y. And 10 divided by 4 is about, so 2.5 equals y. 2.5 equals y. All right. So that would be our initial value of 2.5. So if we take that, we go 2.5 times 4, and then it's going to be to the x power. So 2.5 times 4 to the 4th power gives me 640. Okay. And then 2.5 times 4 to the 25th power is some big number. So I'm just going to write 2.5 and then times 4 to the 25th power. Big number. You could write it on your worksheet or you could write it on your paper if you're just taking notes. All right. Let's clear this out. Go on to the next activity. All right. Bridge 3. Now, these are very simple, but they're important. A lot of times, students nowadays, some of you may know your multiplication facts better than others, as well as multiplication properties. This is a matter of properties. And I'll probably post a link to the properties in the chat. Any number times 1 equals that number. So 2 times 1 is 2. Now, this 2 times 1/2. I like to say, well, what is half of 2? That's going to be 1. But you could also do 2 times 1 over 1 times 2, and then you get 2 over 2, and any number divided by itself equals 1. Same thing here, 2 times 3 over 2, so I could say 2 over 1 times 3 over 2, and that gives me 6 over 2, and 6 divided by 2 is 3. All right, here 5/8 times 1, any number times 1 is that number, so 5/8. Here, 5/8 times 1/2. Well, 5 times 1 equals 5. 8 times 2 equals 16. We cannot reduce that, so that's that. We're going to do the same thing over here. 5 times 3 equals 15. 8 times 2 equals 16. We cannot reduce that either. What do you notice or wonder about the results when you multiply by 1/2 compared to when you multiply by 3/2? Well, when you multiply a number by 1/2, you take half of that number. It gets smaller. Versus when you multiply a number by 3/2, it's going to be 3/2. If we change it to a mixed number, it's 1 and 1/2. So that number should get larger, okay? So that's the explanation of that. The last video is very long, so I'm kind of going fast through this one. Let's get into the activity. I think this is the main one. Yep, this is the last part. Suppose a UNC Charlotte student is chaperoning a communities and schools trip to the North Carolina Zoo in Asheboro. A diagram is provided to help with the first question. Create additional diagrams as needed. Be prepared to explain your reasoning. Very important piece. It says the distance between UNC Charlotte and Asheboro is about 60 miles, and the driver has driven 1/3 of the way. How many miles has she driven? Okay, so if we do a diagram on this, as you can see, 0 to 60, that would represent the one whole. Okay, so if we want to break this into thirds, right? So 1, 2, 3, 4, 5. There's 6 sections. Okay, so that means this would be 1/3. This would be 2/3, right? And then of course this would be 3/3. All right. Well, 1/3, we could say 1/3 times 60. Or if we look at this diagram, well, half of 60 is going to be 30. And so if we count backwards, there's 20, 10, and then 40, 50, and then as you can see, 60. So how many miles has she driven? She's driven approximately 20 miles. Actually, it's not approximately, it's exactly 20 miles. How many miles remain? Okay, from 20, 10, 20, 30, 40. So 40 miles. All right, that should be rather simple for most people to catch. Pause it if you need to. All right, let's go. She has driven 2/5 of the way. Okay, so now we're going to take this same thing and we're going to draw another diagram. But in this diagram, what I want to do is I want to make this one fifths. Okay, so here I got 0, I got 60, and I'm gonna break this down into five spaces. 1, 2, 3. Nope, that's not gonna work. It's not spaced out enough. All right, so let's say 1, 2, 3. It's still not spaced out. I like my fractions to be pretty good. Let's do it like this. 1, 2, 3. There we go. That's a little better. All right, so if I have 5 sections, then let's think about it. Okay, 60 and 2/5. So 10, 20, 30, 40. Well, that's not going to be right. So let's see. If I do 60 divided by 5, that's going to give me 12. So 12, 24, 36, and 48. Okay. Now the fractions would be 1/5, 2/5, 3/5, 4/5, and then 5/5. These fractions are important. Don't be no chump. Don't be scared of no fractions. So as you can see, if she drove 2/5 of the way, she drove 24 miles. Okay. And it says how many miles remain? That's 60 minus 24. So it should be 36 miles. Okay. Same thing in this next scenario. A little different though. All right. So it says the distance between the cities is 300 miles and she has driven 1/6 of the way. So we're going to turn this into 300 miles. All right. So I have 0 and then I have 300 miles. And we're doing 1/6. So let's break it in half and then break those two halves into thirds. Boom. So here we go. So this would be 1/6, 2/6, which is also 1/3. 3/6, which is also 1/2. 4/6, which is also 2/3. 5/6, which is just 5/6, and then 6/6, which is 1 whole. All right, so let's think about it. 300 divided by 6 equals what? 50. So here we go. 50, 100, 150, 200, 250, and then 300. So if she drove 1/6, she drove 50 miles. And then that would mean there are 250 miles. That is not the 50. 250 miles remaining. Okay? 250 miles. Boom. So notice there's a couple ways, or you could also do 300 times 1/6, which is the same thing as 300 over 1 times 1/6, which is 300 divided by 6, and that's 50. Okay. Just I forgot to show y'all that when I was doing that problem. All right, let's move. Number 4, it says the trip is X miles long and the driver has gone 1/4 of the way. Write an expression to represent how many miles remain in her trip. This is important. Okay, so here's a diagram for that, right? So notice the entire length is X. Okay, so from 0 to how many, so X, or if this was a number line, we could put X here. Okay, same thing, right? So X minus 1/4 X, right? Because we're trying to figure out how many miles remain in her trip. So X is the whole thing. So notice we have X minus 1/4 X. Well, when you have X minus 1/4 X, right? There's a coefficient of 1 right here. And now, so when I do this 1 minus 1/4, and keep that times x. Notice this is the same thing as 4/4 minus 1/4. Okay, so 4/4 minus 1/4, keep your x, and then that equals 3/4 x, which you can see right here. Okay, very, very important that you know how to add and subtract fractions when we're working with this exponential stuff, because we're getting ready to start working with some fractions in regards to our exponential values. Okay, I think this might be the last slide, if I'm not mistaken. And it is. All right, so we can stop sharing here. Remember, stop it, rewind it, type questions in the chat if you have to. I'll answer those questions. I always respond to questions in the chat and comments and things like that. Thank you so much for watching and paying attention. I hope you learned something from this video. Do me a favor, share it with your homies that don't do their work. Tell them, hey, Mr. Harris giving you the easy way. Go back and copy it. If you're not in school, go back and copy it. If you do have questions, do me a favor, send me a message, or you can post your questions in the comments. And I appreciate each and every one of you for watching. Remember, Harris got the solution to your math problems. Deuces.